multi-step equations part 2. So now we want to take what we've learned about solving equations to the next step by including brackets in our original equations. So this is where we're going to have to use the distributive property. So we're going to follow the steps listed below when solving equations that involve brackets. So first we're going to multiply to remove the brackets, so that's the distributive property which we learned in the last unit. Then we're going to simplify wherever possible, so we're going to combine our like terms. And then we're going to start by isolating the variable or isolating the term involving the variable by using inverse operations. So we're starting with addition and subtraction. And then we're going to take it even further by isolating the variable by using the inverse operations of multiplication and division. So as we've done in the previous lessons, so we're going to look at solving these equations. Some of these examples we're going to verify our answer by using the left side, right side check, and some we won't. And we're going to use the shorter method of solving for our equations to make our steps just a little bit simpler. But as I said before in our previous videos, you're welcome to use whatever method works best for your thinking and learning. So let's go through a couple of examples. There's only 3 examples that we're going to work through today. The last example we'll do our left side, right side check for. But let's start with example A. So we want to solve. So when you see the word solve, that means you need to find out what value of x will make this equation true. And we do that by solving the equation or isolating that variable. So the first thing you want to do is you want to apply the distributive property. So we want to multiply the term outside of our bracket by everything inside of our bracket. So 3 times x is 3x. And 3 times negative 2 is negative 6, and that is equal to 15. So we don't have any like terms, so we have nothing to simplify. So now we can start by working on isolating our variable, and we do that by first moving over the terms that are being added or subtracted to the variable. So we're going to start with our subtracting 6. So the opposite of subtracting is addition. So we're going to add 6 to the right hand side. So I have 3x is equal to 15 plus 6. I'm going to simplify my right hand side. 15 plus 6 is 21. And now I'm going to isolate my variable even further by exploring the terms that are being multiplied or divided by that variable. So we're going to start with our 3. The 3 is being multiplied by your x. So when I bring it across the equal sign, it's division. Division is the opposite of multiplication. So I'm going to have x is equal to 21 divided by 3, or x is equal to 7. And that is the final answer when we're asked to solve an equation. So we've isolated the variable, so the x is all by itself, and we have one numerical answer for our x. So example B, you'll notice that our x's are on the left or right hand side of our equation rather than on the left hand side. And that is perfectly fine. We can keep them on the right hand side of the equation. So we're just going to be doing things a little backwards in terms of instead of moving things to the right hand side, we'll be moving things to the left hand side. So don't be alarmed if you see your variables on one side versus the other. But we're first going to start by removing our brackets by applying the distributive property. So we're going to multiply each term inside of our bracket by the term in front of it. So we're going to multiply each term by negative 4. So I have 23 is equal to 7x. Negative 4 times 3x is negative 12x. And negative 4 times negative 2 is positive 8. So once I've eliminated those brackets, now I can simplify my like terms. I have a 7x and a negative 12x, so I can simplify those two to get one term, one x term. So 7x take away 12x is negative 5x, and that's still being added to my 8. So now I want to start by moving some terms to the left-hand side now. So I'm going to start by looking at the term that's being added or subtracted to my variable, which is my positive 8. So when I bring it across the equal sign, it's going to be the opposite of addition, which is subtraction. So I have 23 take away 8 is equal to negative 5x. And 23 take away 8 is 15. So 15 is equal to negative 5x. So now I want to isolate my variable even further by looking at the term that's being multiplied in this case to my x. So the opposite of multiplication when I bring it across the equal sign is division. So I have 15 divided by negative 5. I always keep the sign that's included with my coefficient, and that is equal to x. 15 divided by negative 5 is negative 3. So negative 3 is equal to x. So it doesn't matter whether your variable is on the left-hand side or the right-hand side. If you want to rewrite this so that it looks like this, x is equal to negative 3, you can. Both of these mean the same thing, so keep that in mind as well. So the last example we're going to solve, so we're going to find the value of x that makes this equation true, and we're going to verify our solution by using the left side, right side check. And like I said, the more complicated the equations are, the more important it is for you to do that left side, right side check if the answers aren't provided for you so that you can make sure that you've done it correctly. There's nothing worse than practicing something wrong and not knowing that you've been doing it wrong and then getting it wrong on a test or an assignment. So make sure you do those left side, right side checks to verify your answers as you are practicing those questions. So our last example, example C, we're first going to start by removing our brackets using the distributive property. We have two brackets here, so we need to think about what is the number that's in front of our second bracket. Well, if there is no number, it's an imaginary number 1, so we're going to think about that as well. So we're going to do two sets of distributive properties in our first step. So we're going to multiply everything in the first bracket by our 2, and we're going to multiply everything in our second bracket by our negative 1. So 2 times 3x is 6x. 2 times 2 is positive 4. Negative 1 times x is negative 1x, but I can write that just as negative x. And negative 1 times negative 5 gives me positive 5, and that is equal to negative 1. So once we've eliminated those brackets, we can combine any like terms. So we have some terms that have a variable, like our 6x and our negative x. So 6x take away x, or take away 1x. Remember, there's a 1 there, so if you wanted to add that in, you can. So 6x take away negative 1x is 5x. And then we need to look at just our constants. So we have a positive 4 and we have a positive 5. So 4 plus 5 is 9, so a positive 9. And that's still equal to negative 1. So I've combined my like terms, I've simplified my equation. So now I can start by working on isolating my variable by first looking at any terms that are being added or subtracted to my variable. In this case, it's a positive 9. Or adding 9. And the opposite of adding a number is subtracting a number. So I have 5x is equal to negative 1, take away 9. I want to simplify what I have on the right-hand side. Negative 1 take away 9 is negative 10. And now I want to finally isolate my variable by looking at numbers that are being either multiplied or divided by that variable. In this case, we're multiplying by 5. So the opposite of multiplication is division. So when I bring it across the equal sign, I'm dividing by 5. So I have x is equal to negative 10 divided by 5. And let's simplify that even further. Negative 10 divided by 5 is negative 2. So we've done a lot of work here, so it's really important to make sure that our answer is correct. So we're going to do our left side, right side check. So we're going to do that using the t-chart. Left side, right side. The left side of my equation is 2 times 3x plus 2 minus x plus 5, or minus 5, sorry. I didn't give myself a ton of room. I'm actually going to move this over a little bit. There we go. Okay, so x and then minus 5. Okay. And then the right-hand side of my equation is a negative 1. So now I want to substitute this value of negative 2 in for my x's. So I have 2 times 3 times 2 plus 2, close the big bracket, subtracting negative 2, that's a negative 2. I apologize, I put a plus 2 there again. So I have negative 2 and then take away 5. So I want to simplify further what I have on my left-hand side. So I have 2, and then inside of my bracket, I have 3 times negative 2, which is negative 6, plus 2. Minus, or subtract, negative 2 take away 5 is negative 7. Simplifying this even further, I have to simplify what's inside of my bracket first. Negative 6 plus 2 is negative 4. And then a minus, right beside a minus when there's a bracket in between, this turns into a positive, so I have a plus 7. So think about this as negative 1 times negative 7 and 2 negatives. When I multiply them together, give me a positive number. Let's keep going. 2 times negative 4 is negative 8, and negative 8 plus 7 is negative 1. So if I wanted to, I can extend that line even further. My left side equals my right side, which is good news. That's what I want to see. So therefore, I can say with certain that x is equal to negative 2. So if you have any questions about today's lesson, please post your questions in the discussion forum on the virtual learning environment or send me an email. Make sure you are showing your steps. Make sure your solutions are formatted in the same manner as the solutions that I've shown you in these sample videos. And happy math!